Okay, I wanted to record a little bit about what our homework was last night. I kind of wanted to talk about just some of these problems, make sure we're all on the same page. You can see this, and so I'm just going to kind of talk about the different pieces here, right? So number 9, you had tangent times cosine. I'm looking at my formula sheet, and I'm looking for tangent because a lot of the times one of the things I like to do is to switch out sine and cosine, or switch everything into some version of sine and cosine. So one of the things we do is we can look up here, and I have to look at my tangent formulas. I can find the identity for tangent equals sine over cosine. So I'm going to switch that out. I did that because I thought ahead. I said, well, if I do this, what's going to happen? I know that if I multiply the cosine times that, it's going to cancel out and leave me with just sine. Now, why did I know to do that? Because I've got a lot of experience doing this. How do you build that? By practicing. In fact, doing these problems, maybe looking at what we did and then starting fresh and trying it again, probably is a great idea for you to do too. The next one is even easier. These are reciprocals, so immediately, if I realize I'm multiplying two reciprocals together, those two things are going to cancel out and give you 1 every time. I don't even need to see your work for that, right? But just to kind of show you how you would work that out, I'm going to change the tangent over, or the cotangent to 1 over tangent. Now that's in my reciprocal identities. I leave the tangent alone. If I multiply that together, obviously the tangents cancel out, leaving me with 1. The next one, I have a little weird one here, right? Now, remember, we have a lot of identities. I'm only going to make you memorize the ones from the tangent, the reciprocal functions, and the Pythagoreans. Here again, if you don't memorize them, you are deciding that you don't want to be as prepared for what's coming as other students. It's not that you need to memorize them, it's you need to have an ability to know how to use them. And that comes by knowing them. In my head, when I see a problem, I'm thinking, these are my options. I have this, or this I could do here. If I don't know those exist, I'm not going to know my options. So it's really important for you to kind of have that mental checklist or that menu you can pick from, and knowing which ones are relevant and available. Rather than saying, oh, here's my formula sheet, I'm just going to look at it and I don't know which ones work. They're not ever going to just jump all the pace. Hey, use this one here. I need to know in my own mind, oh, I need the formula that looks like this, and go find it, and oh, that's what it is. Maybe I could remember what it looked like, so I go to my formula sheet and kind of work it out. Be careful, okay? Here again, this is a cofunction identity. If you look at that, so I believe it's on the left side. It's like the second or third row down. You'll see it there. It says cofunction. You're going to find something that says sine of pi over 2 minus, I believe they use theta on the formula sheet. The variable names will change all over the place. You can leave it as x or theta. That won't really matter. But I can put this in here, and I see that this is just equal to cosine of the same variable, right? So secant, here again, reciprocals, they're going to give me 1, but just to show you, and be honest with you, I don't even need you to write this part. You could go straight from here to here, and you would be good on that. Number 12 is exactly like number 9. They just did kind of the reverse of that. Instead of cosine, or instead of tangent, we have cotangent. Flip that over, I'm looking at my tangent identities again, and then I'll bring that down, get some cancellation to happen, and I've got cosine of u. Okay, 13. Remember, there are a few tips that I like to give out. The first tip is kind of what we've already said. Change everything to sines and cosines when you can. You get more options when you do that. Number 2 is when I have trig functions that are squared, like this. I really want to take some time and go into looking at my Pythagorean identities. Right? If I look this up in my Pythagorean identities, I see this whole thing is equal to just secant squared x. Right? And then we'll go back to my original one, ones we used up here and down here. I'm going to go to sine and cosine. So I take this and this. That's 1 over cosine, but it's squared. So make sure I'm squaring those values. That's 1 over sine. Do this. And now I'm just going to do a little bit of algebra, and I'm going to multiply by the reciprocal. So I flip this over, multiply through, and I get sine squared over cosine squared. That sounds familiar. I've used it up here, except now it's squared, so it's just equal to tangent squared, right? And that's my final solution. In 14, this is exactly like 13. They just kind of changed up the numbers a little bit. the trig functions, and so I've got another Pythagorean identity on the top that's equal to sine squared. Sometimes in the Pythagorean identities you might have to add or subtract a piece to the other side to make it look like what you have. In this example, we have to subtract cosine squared from both sides, from its original state, to make it look like this. And so once I do that, I get sine squared on the top, and of course it cancels with the 1 on the bottom, leaving me with just sine here. 15, here's another tip. Sometimes the GCF, if I have multiple terms, 2, 3 terms, sometimes I can factor out something in common, and it really makes my expression easier to simplify, especially with 2 terms. Here, I can see that I have cosine and I have cosine cubed, right? Obviously, the common factor is cosine. I'm going to factor that out. Remember, when you factor, it's a lot like dividing. So cosine divided by cosine is 1. Cosine cubed over cosine is cosine squared. Some people want to say that if I'm factoring all of one term out, I'm left with a 0. That is not true. That has never been true. You have to be careful. Once you factor it out, if I were to multiply back, I should be able to get what I started with. If I can't, I've done it wrong. Here again, 1 minus cosine squared back over here. Do you see how things kind of repeat over and over and over? That's what's going to happen. You're going to make the same kind of substitutions. If you don't know those things exist, you're going to have a hard time knowing what to do with it. So this is what you see. Kind of watch for the patterns. I get cosine to come down here, but this becomes sine squared. That doesn't simplify anymore. Sometimes you get a situation like this where the result doesn't seem like it's a lot simplified like these are here. I realize that on tests and quizzes, I try not to give you things like this where like, am I finished? I don't even know. So don't worry too much about that. 16, sometimes you have lots of pieces. Now, we kind of made fun of this, but sine squared plus cosine squared equals 1 is your very first Pythagorean identity. We're going to call that the big boy. I didn't name it that way. It happened a decade ago in another class, and it kind of stuck around. But we make a joke of it kind of to draw attention to it, because sometimes that particular formula sits right in front of you, and you don't even realize that it's there. And in 16, this looks really complicated, but remember, we can add in any order. Everything you've ever learned about math, algebra, solving equations, that's all going to come to light in this unit. It's really important you go carefully and not be too careless with your algebra here. I'm going to rewrite this. I'm going to put the sine squared and the cosine squared together because we can add in any order. So it works out that way. Sine squared plus cosine squared, that's just 1. So 1 plus tangent squared, that's also a Pythagorean identity, which is secant squared. So secant squared over secant, obviously we can get one of them to cancel out, leaving me with just secant of u over 1, or just secant. Now, this has a u. If you don't like u, you can put an x or theta. It's up to you. Be careful. These kinds of things are definitely helpful when you are practicing this. In fact, if I were you, I would pull this back up and I would try it all over again. Don't look at the answers. Just try it yourself and see. You've already seen it. Can you do it now? Right? If you can't, there's usefulness in just redoing this. In that worksheet we're working on today, if you haven't seen those before, or maybe you've gotten a couple of them, I'm going to post a video for at least one of them, maybe 2 of them, to kind of give you an idea. And you need to practice it. Do it again. If you've got the answer, can you do it now? Right? That repetition, it's experience that you get ideas of how I'm substituting, how I'm making these things change into something that's simpler. The best teacher here is definitely going to be your experience. The more people that do this, the more comfortable you're going to get with these kinds of questions. If you guys got any questions, please let me know. Send me a message, and hopefully I can get you a little bit of help, whether we do a video like this or I can just email it back. So I'll see you guys later.